So yesterday, what I was showing you was that let me go to. I had shown you that, I mean, obviously you have these 9 chapters for your P3. Very, very important. And we have differentiation, integration, and differential equations as part of calculus. Connected is one thing. So if you see here, we talked about differentiation and the methods. We talked about how you differentiate. I told you that you have the 5 types of functions, and we were looking at how you must differentiate each of the 5. So, before starting today's lesson, I just want you to look again at the 5. Look nicely, students. Don't let me down. Look at this. Logarithmic is ln x. This is the logarithmic function that we should know. Ln x is the logarithmic function we should know. And when you differentiate it, you get 1 over x. So ln x, that's the logarithmic one. Ln x. The second one in your 5 types of functions that you must know how to differentiate. The second is inverse trig. And the only inverse trig you must know is tan inverse of x. And when you differentiate it, this is what you get. Then the third one, the third type of function, these are the types, the 5 types of functions. The 5 types of functions and their derivatives. Third will be algebraic. And when you differentiate it, we said you just use the power rule, where you drop the power and reduce it by 1. So algebraic is like x cubed plus 2x squared minus 9. These types, these are the algebraic functions. X something, x something. Then we saw the 6 trig functions and their derivatives. And it will be sine of x, cos of x, tan of x, sec of x, cot of x, cosec of x. These are functions of x and their derivatives. Sine x, cos x, tan x. That's the trig. Don't create your own. It's sine of x. The last is E on the 5 types. L logarithmic ln x. I inverse trig tan inverse of x. Its derivative 1 over 1 plus x squared. A is algebraic functions, also called polynomials. How do you do them? Drop the power and reduce it by 1. Okay, drop the power on x to multiply and then reduce it by 1. Then you have trig functions. Then you have the last, which is E, exponential functions, where you have y is e to the x and its derivative is still e to the x. Right. Knowing this is what leads us to today's work. I told you that Cambridge will never be this nice to give you sine of x. That's very rare. Instead, when they will give you this, they'll give you a sine of maybe x squared plus 5x or whatever. This is more like the one you will get. But you must know that this is not the trig function. The trig function is sine of x. This is sine of something which is not x. This is sine of something which is not x. So that means the function has been changed. They have put something where there was x. And once that happens, you have to use the chain rule. So let me give you the rules, then we go and do the questions in the exam. So listen, we saw how to differentiate these functions, and we said this table you will be given in the exam. So this table of the derivatives will be given in the exam. But what we must know is the rules that come after this. What happens when you combine functions? Wait, yes. Why did the pages get mixed up? I'm not sure why the pages are mixed up. Let me fix the pages, sorry. Should be like this. So this is the table which shows you, which we'll have in the exam. Then we saw what happens when the functions are now being combined. To say, okay, well done, you now know how to differentiate sine. To say it will give you cos. And cos to know what it will give you, cos of x. Well done, you now know. But what if you asked differentiate sine x e to the x? Sine x cos x, or sine x whatever. To now multiply. We said you use the product rule. When two functions in this table are multiplying each other, in other words, written next to each other, then you must use the product rule. The second rule, and the product rule, we saw it, it's if y is uv, what do? You bring the second one, multiply by derivative of the first, plus bring the first, multiply by derivative of the second. Second times derivative of the first, plus the first times derivative of the second. This is the product rule that you must practice. Then we go to the second type of rule, which is called the quotient rule. It's called the quotient rule. This one used when two functions in lineate are dividing. This you will use if you ever get two functions dividing. E.g., y is equal to e to the x over sine x. Okay? To find the derivative, you must use quotient rule. So quotient rule is only for differentiation. That's the only time you ever hear it. Product rule is only for differentiation. That's the only time you ever hear about the product rule. Are we together? November, are we together? Derek, are we together? So now, here is what it says. If y is equal to u over v, this is the u, okay? So this is an exponential function, which makes it the u. What about sine x? What type of a function is sine x? Sine x is on our list, trig function, which makes it the v. So we have a function divided by another function. The only way to differentiate it, is to use y is u over v. You cannot use product rule if you have e to the x to say, I'm going to change this to be e to the x sine inverse of x. Don't do this because you don't know how to differentiate sine inverse. So you use quotient rule. Keep it as a fraction, Mr. R. And then you now say, if y is equal to uv, this is now the quotient rule which I'm giving you. dy dx, okay? You can say then dy dx, the derivative, is equal to, here is what you say in when you're doing this. You say, I want to put it in brackets, low d high minus high d low over square the bottom. Okay? We've used this for many, many years. It works. Low d high minus high d low over square the bottom. What does this even mean? High is, it means the function at the top. Low, it means the function at the bottom, the v. So you have u over v. It means you have high over low. The derivative will be low, which means v, d high, which means the derivative of the top, minus high, u, d low, which is v prime, over square the bottom, which is v squared. This is your quotient rule. Low d high, don't change. Sometimes people change to say high d low minus low d high. No, no, no. It's low d high minus high d low over square the bottom. Low, which is v, d high, which means the derivative of high, which means u prime, minus high, high is u, d low means the derivative of low, which is v prime, divided by square the bottom. This is the quotient. Do you see how to do it? Low d high minus high d low over square the bottom. So just like the product rule, the first thing you would need to find is you need to choose who is your u, who is your v. Find u prime, find v prime, then use them in the formula. Just like we did for product rule. For product rule, when we did the example, we'll do an example just now. This example, we had to choose who would be our u, who would be our v. So this is the one you were given. Then we chose to say, let this first one be u, then this second one be v. Then we found u prime, and we found v prime. Then we used them in this formula. This is our product rule. This is the formula where we used it. And you just go on and get your final solution here. What made you get the final solution is you used the formula. You used the product rule. You identified that you had two functions from Lie8 multiplying. So we're about to get to the real deep part, the last part. So let's do this one. Let's do this one, students. Here, let's say for example, here's an example. Find the derivative of, let's say, I want to make it simple. Ln x over cos or over cot x. Find the derivative of ln x over cot x. What do you do, students? What do you do? What is it that you recognize here? We have a quotient. We have two functions dividing. Remember, ln x is what type of a function? Logarithmic. So you can identify we have a logarithmic function. being divided by what type, Mr. Derek? Cot x is a what? Well done, is a trig. So we have a logarithmic being divided by a trig. When functions divide, it's quotient rule. When they multiply, it's product rule. So we are just going to rewrite it. Okay. Find the derivative of y equal to, by the way, I forgot to put y. So you now, for solution, you are going to first rewrite what you have been given. So the first part is to rewrite. Y is equal to ln x over cot x. Then now you're going to say, let u be ln x, v be the bottom, okay? This is u, which is high, and then this is v, which is also low. So v is cot x. That u prime is the derivative of ln x, which is 1 over x. V prime is the derivative of cot x, which is negative cosec squared x. It is cosec squared x, but you must not forget the negative. These derivatives are easy. You take them from the MF19 booklet. I'll take you to them. Now you're going to say, if y is equal to u over v, then dy dx is equal to low, which is v, d high, the derivative of the top, minus, it's not plus, high u, d low, v prime, over square the bottom, v squared. Low, d high, minus high, d low, over square the bottom. So you can now put your dy dx to say, that means that dy dx is going to be equal to, what is low? Here, cot x. Multiplying d high, the derivative of the top, 1 over x, minus u ln x. Multiplying the derivative of the bottom, negative cosec squared x. Divided by, square the bottom. So you take the v and you square it. So it's cot x all squared. Then all you have to do now is simplify. You have applied this formula, this very important formula called the quotient rule. Right. Cot x over x, then you have minus, and another minus becomes plus ln x cosec squared x divided by cot x all squared. This is your answer. Cot x times 1 over x, cot multiplies the top. That's why you get cot x over x like this. Now we are at the third and final rule, which is the secret to everything. The third rule is called the chain rule. The third rule is called the chain rule. It is used when you have composite functions. It is used when you have composite functions. Are we together, students? Composite functions, I want you to say here in brackets, a function of a function, which just means a function inside another. A function inside another. The word composite means function of a function, which means when you have one function, not multiplying, not dividing, but getting into another. Are we together? Yes. This, you have to use the chain rule. Now, let me give you the simple, let me show you examples. Then I show you the simple. I know that there is a chain rule. You would be told, hey, let you be. Then this. I'm not going to do that one. Waste of time. Absolute waste of time. So listen to what the chain rule just does. Right. Let's put examples. Let's just put examples. Examples of composite functions. Examples of composite functions. Let me ask you a question. What type of a function is this one? Remember, what type of a function is sine 3x? Remember, are you around? Remember? Okay, what type of a function is this one? Sine 3x. Good, I wanted you to say that. I'll say wrong. Remember, go to the table of trig functions. Did you write the table down? Tell me, what trig function do you see with sine? It was sine what? Sine x. Good. Is this sine x? Remember? This is sine what? So why are you saying it's a trig? Once you change the x on any function, beware of this big mistake. Once you change, in the table that I gave you yesterday, I showed you that sine x is the trig function. This is not sine x. This is sine 3x. So this is no longer, yes, Raja, this is no longer a trig. On the trig table, let's look at it. On the trig table, well done for saying composite, Mr. R8167. On the trig table, I showed you sine of x. This is not sine of x. This is sine of 3x. So already you now have a composite function. They have put 3x in place of x. So you are going to have to use the chain rule. If you don't use the chain rule here, the answer you get is wrong. And I'm going to show you how you do the chain rule. First, I need us to agree on these. What about this one? E to the, let me say, e to the x squared plus 5. Mr. Derek, what type of a function is this? Okay. The word exponential would be so wrong on this because on exponential, we did only 5 types. We did only 5 types. On exponential, it was e to the x. Mathematicians, listen. When you change this x, you no longer have an exponential function. If you come to the logarithmic function and change this x, you no longer have a logarithmic function. No. it becomes composite. Once you change my x, I will now need 2 steps to differentiate it. So this was going to be exponential if it was e to the x. This one, if it was e to the x, we would have said it's exponential. But they have changed the x. And they have put a big thing here, x squared plus 5. This makes it composite. There is this guy inside of e to the x. So in e to the x, they have put this x squared plus 5. In sine of x, they have put 3x. So it's now sine of 3x. So if you get anything, sine of e to the x, sine of cos x, sine of anything x squared, anything which is not x, as long as it's not x, then it is a composite function. This e to the x is inside. I did not say sine x e to the x. No, 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 no. If it is sine x e to the x, then they are multiplying. But it is sine of e to the x. E to the x is not x. So they have removed x on sine x and put e to the x. That makes it composite. So the biggest thing you can do, a sign that you are mastering differentiation. Hi, real Barbara. 7. A sign that you are mastering differentiation is you can see composite functions. They will be there everywhere. And I need to show you how we differentiate them. Let me give you one last one. This one is for you again. Remember? X squared plus 5x minus 9 all to the power of 5. What type of a function is this one? Remember? What type of a function is this one, everybody? Are you there, Rainbow? On the list, what type of function would this be? Which is x and powers and just this. This would have been the easiest, the polynomial, right? But look what they've done. They've come to our polynomial and they have, it would have been polynomial if it was just x squared plus 5x minus 9. But now they are taking the whole polynomial and giving it a second power. A second power outside. Thank you, Mr. The Goat Dude. Look, they are now taking our nice polynomial. Make no mistake, this is the polynomial, the algebraic. But once you put another power outside, it now becomes composite. So we must use the chain rule. We must not ever use anything else. We'll be in serious trouble. Here is another one they like to use. Put a big square root on x squared plus 5x or whatever. Look at this. X squared plus 5x. Well, what we know is if I look inside here, this is a polynomial. X squared plus 5x is a polynomial. Nobody should struggle with the polynomial. It's the easiest. X and powers, x and... But there is a problem. The whole thing is being affected by another power again. Because square root means power half. So the whole thing is to the power half. So there are things inside and another function outside. this becomes composite. So we have a composite function again. Oh, you have a composite function? Yes. So how do you differentiate composite functions? You use chain rule. Chain rule is used to differentiate composite functions. And here is what it says. It's a statement, okay? Chain rule is a statement. You will be using the tables I gave you, so you're not going to learn anything new. But you must stick to this statement. Here is what the chain rule says in simple. In simple. Chain rule, it says, step number 1, differentiate. I'll do an example. Differentiate the outside. Differentiate the outside without changing the inside. This is where a lot of people get it wrong. Differentiate the outside without changing the inside. Differentiate the outside, but don't change the inside. Bring it back as it is. Then to multiply by derivative of the inside. So we will differentiate the outside without changing the inside. Then you multiply the answer by the derivative of the inside. So let's do these ones which we wrote as examples. Okay? Differentiate each of the following. With this, I can do some examples in past papers. Okay? Let's just do this one and then I'll show you in past papers how you can apply what I've just taught you. Differentiate each of the following. We put all the things we did. Sine 3x. B. E to the x squared plus 5. C. Even if it was e to the minus x, this is still a composite function because minus x is not x. So it's a composite function. D, cos of negative x. Cos of negative x, still this is a composite function. Let's put e, these ones that we wrote. This one, x squared plus 5x minus 9 to the power 5. Then the last one, square root of x squared plus 5x. Differentiate each of the following. Good. At R8167, I can see your answers are good. Let's put the solutions together and we check if yours are all correct. Now, the first part of being a good, by the way, I forgot to say y equal to, I want you to have it as y equal to. Okay. So now we start with the solutions. Let's do them fast. Y is equal to sine 3x. So the issue is not really the chain rule. The issue is, please be able to quickly see when you have a composite function. That's the one that's coming in the exam 99% of the times. Let me just show you. Here are the functions. The 5 functions. We have logarithmic, and it's just ln of x. So if you ever get ln of anything which is not x, it is composite function. tan inverse of x sine, this is the inverse trig. Then the sixth trig are sine of x, cos of x, tan of x, sec of x, cot of x, cosec of x. Then the last is e to the x. Everything is x, 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 x. Once you start putting anything which is not x, it becomes composite. And I should use the chain rule. But the chain rule will still use this table, but it will be applying the principle that you must differentiate the outside without changing the inside. Then multiply by derivative of the inside. So here we would say it. Let's do it. Solution. Here is y equal to whatever. Then now you say dy dx, the derivative, is going to be equal to. So here everybody can see that this is a composite function. It is a sign which we do not recognize. We only recognize sign of x. But this is sign of something which is not x. Don't let me down. You should see it. So now differentiate. How do you differentiate? You start with the outside. So this is the inside. This new guy who has been put on position of x, he is the inside. The outside is sine. This is the outside. So you should differentiate the outside without changing the inside. Don't change the inside, please. So let's differentiate the outside. What's the outside? It's sine. How do you differentiate sine according to the table? The table tells you the derivative of sine is cos. So if I'm differentiating sine, I'll get cos. So I'm going to say the derivative of sine 3x is cos. Cos what? 3x. So why did you say cos 3x? Because we are not yet touching the inside. We are bringing it as it is. Cos 3x. Then we multiply by the derivative of the inside. This 3x. What is the derivative of 3x? It is 3. So the final answer is 3 cos 3x. Yes, I see you got a lot of them. Well done. Here, have you seen it? This is your solution. Have you seen it? Now you do part B. So you differentiated the outside to this. And when you brought it back, the inside was still the same. Then you multiplied by derivative of the inside. Don't let me down. Let's see the second one. Okay, I want you to master this. I'll be so proud of you. Y is equal to e to the x squared plus 5. What you will know, you know how to differentiate e to the x. It's there in the table. Check your MF19, it will be there, so you're fine. But here you have an animal. This is not x. So this is obviously composite. They have changed my x and put something I don't recognize. So I must use the chain rule. Chain rule says you must find the outside and the inside. The inside is the one that replaced x. Who replaced x? This is the inside. Then e is the outside. So when you're differentiating e, you use what you were told in the table. The table told you that when you differentiate an e to the something, e to the x, it comes back as it is. Nothing changes. So when we differentiate this e to the x squared, whatever, the derivative of e is it comes back And you can't write it as e to the x. No, because the inside should come as it is. So the inside will come. It will be e to the x squared plus 5. But then you have differentiated the outside. Well done. You've differentiated the e. When you differentiate e, it doesn't change. But then you must then multiply. This is why you should know how to use the chain rule, because you must use the chain rule. You should then multiply by the derivative of the inside. What's the derivative of the inside? Derivative of x squared, 2x. Plus derivative of 5, nothing. So we then just multiply by 2x, which makes it our dy dx. It should be then 2x, then e to the x squared plus 5. This becomes your final solution, and you would have done it correctly. Are you seeing? Yes. Yes, I like that. Are you seeing? Good. Right. Let me see if I have a problem in the table. Yes, these two are negative, by the way. I don't know why these are not negative. Make sure these two are negative in the table. These two. We said it yesterday that they should be negative. Cot gives you negative cosec squared. Cosec gives you negative whatever. Now, let's do. Don't make a mistake. That is where practice comes in. Y is e to the negative x. So the first thing of any mathematician. So what I'm teaching you, so there are two ways to do maths. One is by intuition, which means I would give you 1,000 problems and we go through them until you now understand what's going on. Then there's the second way, which is called first principles. First principles is this. When you are studying, you go into the mind of Einstein or the mind of Newton. You go into his mind and you look, what was Einstein seeing, or what was Newton seeing, or any mathematician? What were they seeing when they introduced the chain rule? So now we are able to see what they were seeing. They were seeing a composite function. A function that was different from the ones they knew. They knew e to the x, but now they had met this one. They had met e to the negative x. Remember that all these functions are from real life situations, calculations that scientists and engineers and doctors are doing. So you meet a situation which gives you this type of a function. You need to differentiate it so you can find the rate of change and all these other things. So you should be able to recognize, oh, this is the composite one. And the method we introduced for this is the chain rule, which says differentiate the outside without changing the inside. Then multiply by derivative of the inside. So here the inside is this, the one which took the place of x. This e is the outside. So now let's differentiate it. We want to differentiate the outside without changing the inside. By now you know that if you differentiate e, we did it here, it comes back as it is. So the derivative of e is still e, which is e to the what? Negative x, because the inside is not yet changing. It comes back as it is. The inside shouldn't change. A lot of people change the inside and make it e to the x, but it was not e to the x in the question. It was e to the negative x. Why are you changing the inside? So then what we then, oh, you know limits. I like that. What you then do, you multiply by the derivative of the inside. What is the derivative of negative x? It is negative 1. So you can now say, Rainbow, dy dx is, and you, Mr. Derek, Negative 1 times this is negative e to the negative x. This is your solution. This is your solution. Wow. Now we can move faster. D, you should do it until you are moving fast now. Cos negative x. Why? Y is cos negative x. Everybody will see that they changed our x. So it's no longer a trig function. It's now a composite function. And because this negative x took the place of x, it is the inside. And this cos is the outside. So when I'm differentiating, I use the chain rule, which says differentiate the outside first. So go to your table. So you must know how to use your table in chain rule. When you're differentiating the outside, you go to your table and see, how do I differentiate this outside, this cos? You go to your table, you see the derivative of cos is negative sign. Let's go to it. The derivative of cos is negative sign. So we'll go, oh, okay. The derivative of this cos will be negative sign. Negative sign of what? Of negative x. Because the inside is not yet changing. But then we then multiply by the derivative of the inside, which is the derivative. By the way, this is dy dx we're getting. We then multiply by the derivative of the inside, which is the derivative of negative x, and that's negative 1. So we then multiply by negative 1, which will give us negative 1 times negative sign. It will give you a positive sign of negative x, like this. There we go. This is your dy dx. Wow! Great mathematician right there. Because you know which method to use and why you do it. Let's do this. X squared plus 5x to the negative 9. Okay, we're almost done. X squared plus 5x to the negative 9, all to the power of 5. So you are almost getting to the last bit of differentiation. What? Yes, you're almost getting to the last bit. The last bit of differentiation is you knowing the last two things, which is how to differentiate parametric and implicit functions. Then how to apply all this that we have been doing. Application of differentiation, which is how you'll be now using the derivative to find tangent, how you use it to find equation of a line, how you use the derivative to find many different things. The rate of change, all this. And we have what we call connected rate of change. So there's rate of change and connected rate of change. I'll explain to you. Here's the function we have. So those will be applications. And to do applications, the first step is to find the derivative. After finding the derivative, then you can now use it. If you can't find the derivative, you cannot use it. So, excuse me. It'll be now dy dx. First thing you must recognize is this is not a polynomial because we have something inside and we have another power on the outside again who's affecting everything. And our inside is this. And this is obviously the outside. So, how do you differentiate? You start by differentiating the outside. Don't change it. Come on now. Stick to the rules, mathematician. You start by differentiating the outside without changing the inside. Let's differentiate the outside. It's just a power. How do you differentiate a power? It drops down and you reduce it by 1. So dy dx, the inside is not changing. The power is dropping down. It becomes 5 here. The inside is not changing. X squared plus 5x minus 9. And it is now to the power of 4. So you have dropped the power and reduced it by 1. Then you multiply by the derivative of the inside. The derivative of x squared 2x, plus the derivative of 5x, 5. The derivative of negative 9 is nothing. So this is what you remain with. And if you want, you can write it as this way. 5, open bracket, 2x plus 5, open bracket, x squared plus 5x minus 9 to the power of 4. They multiply each other. This is what you show. Well done. Derivative of the outside without changing the inside times the derivative of the inside. This is what. Are we together? Are you seeing the chain rule? Are you seeing it, everybody? F. Y is the root of the last one. X squared plus 5x. Composite function. Because we can call it a composite polynomial. Yes, you're correct. But I want you to stick to saying composite so that you see the difference. This is the polynomial if it just comes like this. But once you have a square root which is affecting everybody, it becomes polynomial. You change it to be x squared plus 5x to the power half. This is still y. Now we want dy dx. Now we want the derivative. And because it is a composite function, we use the chain rule. Chain rule, yes. You should identify your outside and your inside. Chain rule says differentiate the outside without changing the inside. So let's differentiate the outside. Drop the power, half. Does the inside change? No. And now reduce the power by 1, because you drop it and reduce it by 1. Becomes to the negative half. When you reduce half by 1, it becomes negative half. Then you multiply by derivative of the inside. Derivative of x squared, 2x. Plus derivative of 5x, 5. So this is what you end up with. Now, this one, I want you to know this one. When something is to the power a negative number, you put it in the denominator to make it positive. So this actually is, you can say your dy dx is half multiplying 1 over, okay, you say half multiplying 1 over x squared plus 5x to the power of half. So x squared plus 5x is now to the power of positive half, not longer negative. And then you multiply 2x plus 5. So now, this is a whole number. It will multiply the top. Then these bottoms will multiply each other. So you're going to say it is equal to 1 times 1 times 2x plus 5 is 2x plus 5 over 2 multiplying x squared plus 5x to the power of half. And to the power of half is just a square root. So you can say it is 2x plus 5 or over 2 square root of x squared plus 5x. This is your final solution. You can go back and rewatch it if you have not really understood something so that you see there's no mistake. This is your dy dx, and this is what we get with the chain rule. Is there anyone who has a question on chain rule? Okay, so let me just show you that in past papers, they'll bring it as a composite function. Even when the functions are dividing, they'll make it composite so that you'll be forced to use quotient rule at the same time as the chain rule. Wow, really? Yes. Oh, that sounds hard. No, it's not hard. I'll show you. So You've done all the methods. You're just left with two more, which is the derivative of parametric and and then the one for implicit. Then now we need to practice. Practice makes perfect. Right. May, June 2025, last year. Paper 3-1, the very first one. Look at this. Okay, these are parametric. We'll talk about them tomorrow. How you differentiate parametric. But even though they are parametric, you see that these are composite. It's not tan t, it's tan squared of t, which is like tan t o squared. This is not e to the t, it's e to the tan t, which makes it composite. So they'll always make it composite. I'll explain to you what just changes on parametric, but it's still composite. Even if we come here, let's go to the other ones. Here it is. Here it is, the differentiation question. Look at this sign. It's sign of what? This is sign of what, students? Sign of 2x. It's not a sign of x, making it composite. Yes. And they've even done it as sine of 2x to the power half again outside. Then also, it then is made to multiply cos x. So there's going to be product rule. But for product rule, we are going to differentiate them separately, the things that are multiplying. So we'll differentiate this one on its own, then this one on its own. But when you differentiate this sign on its own, it is a composite one. So we are going to use the chain rule to differentiate it on its own before we put it in the formula for product rule. So it's going to be very interesting. You see, they won't give you nice situations. They'll make it a composite function. Be ready. We're going to do a lot of questions this paper tomorrow going forward. So we're going to do a lot of questions from past papers together. Right. Once I just teach you parametric and implicit, then we can get to it. Right. Even if I open one more paper, paper 3-2, we are already expecting it. We will not be surprised. We are already expecting it. Yes, at R8167. That's very correct. I like your parametric, Solve the equation? No. Expand? No. 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 But this one, yes. Derek, this is sign of what? Of 2x, which makes it composite. So when you're going to be differentiating, it's not a trig. So that is why it's very hard to use your tables, because people don't know how to use the tables when they are doing a composite function. So the tables become useless. But you know that you are going to use the tables when you're differentiating the outside, when you differentiate the sign. When you differentiate the sign, you look at it, then whatever. You then multiply by derivative of the inside. We'll work on it. But this is a composite function. Ruba, what is this one? Cos of what? This is cos what? good. It's not just your cos x. So we know that in the table we have cos x. But now they've given us cos x all squared, which makes it nicely composite. So we are going to have to apply the chain rule again. Make no mistake about that. So are we surprised? No. Are we shocked? No. Are we expecting it? Yes. And still it will be also product rule because these are also then multiplying each other. So this is the highest level where you have composite functions multiplying each other. We still use the product rule, but as we are using the formula for product rule, we use chain rule in the steps. We'll see as we do the derivatives tomorrow when you are differentiating individually. Right. This is it. I'm going to give you about 10 questions to just do for revision. Well done, everybody. We meet again tomorrow, same time. Are we together? All right. Goodbye and good night.